Morning student. Today we are going to start the new chapter polynomials. In this we have to learn about the types of polynomials, zeros of polynomials and their geometrical representation. So let's start the topic polynomial. Some examples of polynomials. 2x plus 3. This is polynomial. Here x is variable, 2 is the coefficient of x and 3 is the constant term. And the power of x, that is the exponent of x, is 1. So this is a polynomial. Let us take some more examples of polynomials. 3x square plus 5x minus 7. This is also a polynomial. Here the power of x is 2. Here the power of x is 1. Now to be a polynomial, it's compulsory that the power of variable, that is the exponent of variable, must be a non-negative integer. Non-negative integer means it may be 0, 1, 2, 3, any number, but not a negative integer, not a fraction. Let's take some more examples. Root 2 x cube plus 7x square minus 2x plus 1. This is also polynomial. Here the power of x is 3. Here the power of x is 2. Here it is 1. But suppose I write like this. Under root x. Now this is not a polynomial because here the power of x becomes 1 by 2. So now this is not a polynomial. If I take only x, then it is the polynomial. Okay, now let's take some more example. Y raised to 4 plus y plus 1. This is also polynomial, but this is, here the variable is y. So this is the polynomial with variable y. Here we are talking about the polynomials which all are in one variable. All these polynomials are in terms of x, and this polynomial, so it's not necessary that it must be always in x or y. You can take any alphabet, but usually we take x. Now 5. Is 5 a polynomial? The answer is yes. It is called a constant polynomial because I can write 5 like this. 5x raised to 0. Anything raised to 0 is 1. So 5 into 1 is 5. So this is constant polynomial. Now let's talk about the types of polynomial. Here the power of x is 1. So this is called linear polynomial. Here the highest power of x is 2. So this is called quadratic polynomial. Here the highest power of x is 3. The power of variable is 3. So this is called cubic polynomial. Here the highest power of y is 4. So this is called biquadratic polynomial. Now the question is, suppose I take the polynomial 2x raised to 15 plus x raised to 7 minus 3. Now what type of polynomial it is? It is polynomial in one variable and the variable is x. We will say this is the polynomial with degree 15. So the highest power of variable is called the degree of the polynomial. So I think polynomial is clear to everybody. Now we will talk about the zeros of the polynomial. In our course, we have to talk about the zeros of linear polynomial and quadratic polynomial. So, let us take a linear polynomial 2x plus 3. Now, what is the meaning of zeros? That value of x, which when putting in this px, we get the answer 0. So, here polynomial is 2x plus 3. If I take x equal to 1, so in place of x, if I put 1, I will get 2. In place of x, I will put 1 plus 3. So, I am getting the answer 2 plus 3, 5. So, I am not getting 0. So, 1 is not the 0 of this polynomial. Now, what should I keep in place of x so that I get 0 answer? So, if I put minus 3 by 2, okay, what I am getting? In place of x, I will put minus 3 by 2 plus 3. So, 2 get cancelled, minus 3 plus 3. So, I am getting 0. So, I say that minus 3 by 2 is the 0 of given px. So what is the meaning of 0? That value of x which gives px equals to 0. That is called the 0 of px. Now, linear equation will have maximum 1, 0. Now, how to find the 0? Okay, so suppose I take the polynomial 2x plus 3 equals to 0. So, I will get 2x equals to minus 3. So, x equal to minus 3 by 2. So, this value of x is the 0 of the given polynomial. So in this way, we can find the value of x, and that value is called the 0 of that linear polynomial. Now this is the general form of linear equation. Here a and b are any real number and x is a variable. Here this is ax square plus bx plus c is the general form of quadratic polynomial. Now see here, the highest power of x is 2. A, B, C, they are any real number. But the condition is a must not be 0. Then only it is linear equation, and then only it is a quadratic equation. So a must not be 0 in both the case. Now see the geometrical representation of the polynomials. First, let us talk about the geometrical representation of a linear polynomial. Now in linear polynomial, it always represents a straight line. It always represents a straight line. For example, if I take a graph, two axes, x-axis and y-axis. Suppose I am getting a line like this. That means this line represents a polynomial, and the 0 of this polynomial is this point on the x-axis. The point at which the line intersects the x-axis, that point, suppose it is 1. Suppose 0, this is minus 1, this is minus 2. So if it is passing from minus 1, that means the 0 of that polynomial is minus 1. Okay, so I think this is clear. Now let's talk something more. Suppose I am taking, the line is passing like this. It is not intersecting our x, it is parallel to x-axis. In that case, it has no 0. Why? Because it is not intersecting the x-axis at any point. So, if a line intersects the x-axis at a point, that point is the 0 of that linear polynomial. Now, let's talk about the quadratic polynomial. Quadratic polynomial represents a parabola. Now, the question is, what is parabola? Quadratic equation have maximum 2 solutions. That means, suppose I am making a graph of a quadratic polynomial. Now, how to solve the quadratic polynomials by different method, that you will learn in chapter 4, that is quadratic equation. Now, parabola means this is called open upward parabola and this is called downward parabola. Now see here, this parabola does not intersect the x-axis. That means that polynomial will not have any 0. This will also have not any 0. Now let's see when we will get a upward parabola and when we will get the downward parabola. It depends on A. If my A is positive number, I will always get an upward parabola. And if my A is less than 0, that means if it is a negative, if the coefficient of x square is negative, then I will always get a downward parabola. Now let's see. Suppose I am getting this type of parabola. Okay, that means this polynomial is having 2 zeros. Why? Because my parabola is intersecting the x-axis at 2 points. So, suppose this is minus 2 and this is 2. That means this polynomial, that is this quadratic polynomial will have 2 zeros. And which are that 2 zeros? Minus 2, 2. Okay, next. Suppose this is x-axis and y-axis and I am getting a parabola like this. That means let it be 3. 0, 1, 2 and 3. Okay. So this parabola, it represents a quadratic polynomial, but this will have only 1 0. That means because it is touching the x-axis only at one point. So a quadratic equation, the quadratic polynomial represents a parabola. If quadratic polynomial have only 1 0, it will touch the x-axis. If it will have 2 zeros, it will intersect the x-axis at 2 points. And if it has no zero, then it will not touch the x-axis. So by seeing the graph, we can tell that how many zeros the quadratic polynomial is having. And the quadratic polynomial will have maximum 2 zeros. Okay. And when we will get the downward parabola, if the value of a, that is if the coefficient of x square is a negative number, then you will get the downward parabola. So I think about geometrical representation of linear polynomial and quadratic polynomial is clear to you. Now exercise 2.1. First question. The graph of y equal to px are given in figure. For some polynomials px, find the number of zeros of px in each case. Now let's see the first one. Now here, this is a straight line. That means it represents a linear polynomial. But it is parallel to x-axis. Is it touching our x-axis? No. So we will say it has no zeros. That means it has no zero. Come to the second one. Now this is not a parabola. Okay, that means it does not represent a linear polynomial or a quadratic polynomial. It may be any other polynomial. Okay, now we have to find that it will have how many zeros. Now you see, this is my x-axis. This curve intersects the x-axis only at one point. So how many zero it will have? It will have 1 0. How many zeros? Only 1. Now come to the third one. See this graph very carefully. This is also not a parabola or a straight line. That means it does not represent a linear polynomial or a quadratic polynomial. Now see here. It is intersecting our x-axis at 1, 2 and 3 points. That means this polynomial will have how many zeros? It will have 3 zeros. So it depends on the curve that it is intersecting our x-axis at how many points. Fourth question. Here this is parabola. It is open parabola. That means the coefficient of x square is a positive number. Okay, now I want to find the number of zeros of it. Here the parabola intersects my x-axis at 2 points. So it has 2 zeros. Now the fifth one, here you see the curve is intersecting our x-axis at how many points? 1, 2, 3 and 4. So this polynomial have 4 zeros. Come to the sixth question. Here you see this curve is intersecting 1 point. Here you see it is not intersect, it is simply touching the x-axis. So 1 point, 2 and 3. So it is here it is intersecting and here it is simply touching it. So 1, 2 and 3. So it has 3 zeros. So in this way, by seeing the graph of the polynomial, we can tell how many zeros they are having. Thank you.